Next, let's talk about the stack information and condition module, which defines the structure information and sets the properties of each layer. On the left, there is a DB Explorer. We already talked about it in the DB information. It shows the DB files used in the program in an Explorer format. When you double-click on a specific DB in the stack information and condition module, the screen automatically switches to the DB information module so that you can immediately check the DB properties. And the material can be easily inserted into the stack list by drag and drop method. Or utilize these icons below, such as add, delete, up, and down. To design the structure, just stack up the layers from bottom to the top or from top to the bottom. And there is a property window. In the property, you can define the layer characteristics. It is displayed differently depending on the layer, so I will talk about it later on with an example. In the output condition, you can set the output criteria and simulation conditions for calculated result data. And there is an option. From now on, I will tell you the options of TechWiz OLED program. If you click this option button or click Tools and select Option, you can set a lot of options. And there are 5 tabs here, and the first one is General. I already mentioned about use the extended wavelength range option in the DB information module. When defining the refractive index, the default wavelength range is from 380 to 780 nanometers. But users who want to define the refractive index from 200 to 2000 nanometers, please check this option. And the next one is to enter the number of cores for the calculation. Lastly, you can select the unit for the thickness, nanometer or micrometer. The next tab is Method. When metal which has the reflectivity value is defined in the stack list, set whether to consider the surface reflection by the external top. And also, use depolarization is to set whether to define the depolarization factor. So, if you check this option, in the optical properties, a depolarization term is added. And the following tab is Solver, which is relevant to the optical analysis method. In the OLED structure, a relatively thick optical film or a substrate is set as an incoherent layer. And there are 3 types: phase split, wavelength split, and add automatic selection. The first one is a phase split. Insert the same number of retarders as the inputted the number of sampling in the lambda divided by 2 range, and then average it out. The second one is a wavelength split. Enter the number of sampling and the range. Split the input range by the number of samplings and set the range to be averaged to the left and right around the reference wavelengths. Lastly, add automatic selection. Within the peak detection range, set as incoherent layers automatically, which has 2 or more peak-to-peak. And if you want to output the additional data such as retardance, delta N, and effective NE and NO, please check this option. Finally, by checking PBS, simulation considering the PBS cube characteristics can be analyzed. In the Color tab, users can set the angle for the color calculation. There are 2-degree and 10-degree observer types. And in the RTH tab, equations of RO, RTH, and N average can be selected.